Welcome here in this warm afternoon. Great you took this trip to this side of the campus on the Green Village. And there are people here from all ages, which is great. My name is Michiel van Dorst. I'm the Dean of the Faculty of Architecture. And it's great for me to introduce you here on this spot, because we have a close relation with the Green Village. But something else, and now I'm showing my age, this is the spot where there used to be the Faculty of Architecture. The high-rise, you might know the model, 13 stories high, I can just see it here when I'm looking outside, was standing here. So you're becoming part of our history. But maybe even much more important, you're a very important part of our future. Because what happened in our faculty on research and education on facades, from my humble experience, it's not my expertise, it's groundbreaking. And it's so important to see the facade more as just a building skin, just as a territorial object. And you're working on that, so really appreciate it. And of course, looking at this building, I think here the fifth facade is a very important one, to keep it a bit cool. It's not only the research that's going on, because I think you're going to present work. I'm curious, although I'm not capable to stay all afternoon, sorry for that. But also very important is the education. What will happen today is, of course, the presentation of the MicroMaster that consists of 7 MOOCs, all related with research and education, of course, on facades. It's indeed also groundbreaking, it's engaging. Maybe some of you followed 1 more, 2, 3 of those MOOCs? Yes, see someone nodding. Yes, how was the experience? Yeah, okay, yeah. So we have one positive student already. I think it's really groundbreaking. It's a different form of education. I know today it's not always useful to sit in a lecture room for 2 times 3/4 of an hour. And this form of education is indeed much more engaging. There's a lot of information brought you with different forms of presenting, so not only in text, but also in movie, etc. Have a look at it. And I think it's so nice that it's specifically the Façade group that presents this, because I hope, as you are groundbreaking in research, being groundbreaking in this form of education might be an example also for other groups in our faculty. I hope so. And now I'm going to give the mic to you, Myro, I presume, to say a couple of words to welcome our guest, head of the department.
You may take this one as well. Thank you.
Yeah.
Number 5.
Thank you. Oh, perfect. Thank you, Michiel. I'm Mauro Overend. I am head of the Department of Architecture, Engineering and Technology, which is one of the 4 departments of the Faculty of Architecture and the Built Environment. I'm really pleased to be here. I think Michiel said it all. Except that maybe to add a little bit on the last thing that Michiel said, I think it's really important for us. We're very proud of the quality of our education at TU Delft, as indeed of our partner universities and others who have collaborated on this initiative. But the reason that we are proud and we are good at what we do, I think, is because we constantly ask ourselves, is there a better way we can do this? And I think in the context of education changing around us, right? The world around us is changing. The world of professional practice is changing. We really should, and we do, ask ourselves, okay, does the model of education in the way we have been doing it for the last several years, is this the way to keep doing it, or are there adaptation changes, different ways, right, of engaging with professionals, with students. And I think this is a perfect example of how we might, as Michiel suggested, how we are trying to explore. And this is the first, I think, the front runner. So we are watching very eagerly, and we are rooting for this project to do well and succeed, which I'm sure it will, because I think we can learn a lot from this pioneering initiative. So thank you very much, Ulrich and the Façade team, for actually being the flag bearer of hopefully a future aspect of our education and delivering it. Thank you. And now,
just give it to someone.
I give it to someone.
Just give it to someone. This is a kind of a proven situation. So yes, this is my boss right now, and this is the boss of my boss right now. But I was his boss, and the two of us, we actually served a lot. So this is also in relation, and that's say something for the next generation as well. So yes, you push it to a certain level, but at some point you also change function. So I was texting with Mauro yesterday that I feel that I'm the sleepy one, while he's now in this peak of his time. We have the last entries of the jury, which is good. So, program for the day, we're going to have a pitch, an innovation pitch, and it's an innovation pitch of learners of the OpenFace program. It's about, and you see already some samples, innovations. They get an, 5 minutes pitch. We said 7 minutes as total number, but we need time to switch, so make it 5 minutes. We know you're going to anyhow talk 7, 5. The online group, which is already streaming this, you're supposed to have your screen ready for presentation. So the first one should know that they're getting in position. This is the computer for the ones which are presenting here. And as you can assume, my name is Uli Knack. I'm going to host this program. The committee, Robert Capell. Robert, where are you? Robert Capell, Octatube. He's the guy really making the weird things. Next video coming about something. Miren, where's Miren? There's Miren. Miren just came from Bolzano, being part of this education program, part of our Bolzano member. Bea. When we were just, yeah, exactly, applause. When we just coming by, I asked her if she would have expected that this is going to happen when we met first, Marcel and me, and her comment was, Maya, I thought these guys are crazy. So, yeah, this is Fabio. Where's Fabio? There he is, there he is. Coming from Torino, being part of it. Talia. A monster machine. She organized all this with Alessandra. It was super hectical yesterday afternoon, as you can imagine, because you saw a location it changed. Imagine getting all the logistics done to change location. Thank you. And she said, yes. And to make it even harder, she's going to have her final defense on her diploma on Friday. Not now, and still is, okay, good. Got the point. Alessandra over there. Marcel Bilo doing the pictures. So this is not a hired photographer. He's actually the engine, and he's the one who taught us all these digital devices, me. This is the committee who's going to judge the 11 presentations which you're going to see now, when you're going to have a coffee break. Coffee break. We have limited amount of cups. You have to hold your cup. Otherwise it's gone and you need to have your hands for the coffee. First team, online.
Good afternoon, everyone in Delft, but it's evening here in Melbourne, and I'm glad to be joining remotely today. My name is Vali, and I'd like to start with a simple question. What if facade performance began before environmental conditions reached the wall? My project, Beyond the Facade, explores vegetation as a living environmental buffer between the street, facade, and indoor environments. Cities face growing challenges from heat, pollution, and energy demand. At the building scale, this affects thermal comfort, air quality, and energy use. And these issues are usually addressed through facade and envelope design, but environmental conditions act before they reach the building. So the question is, can we intervene earlier? This diagram illustrates the core concept. I propose the front yard as a living environmental buffer zone positioned in front of the facade. Vegetation is not only landscape, but an active environmental layer that modifies solar exposure, airflow, pollutant transport, and the near facade microclimate. The concept is informed by both field measurements and environmental simulations across the street, yard, facade, and indoor. This reframes vegetation as part of environmental performance, not just aesthetic. To evaluate this, I used validated ENVIMET simulations, comparing vegetated and non-vegetated conditions. The results show clear reduction in facade surface temperature, along with a lower shortwave radiation and sensible heat flux. This improves the thermal conditions around the building and supports better indoor environmental performance. More detailed results are available in my published indoor air study. Finally, the concept translates into design guidance. Vegetation strategies should respond to orientation, solar exposure, prevailing winds, and local microclimate conditions, allowing different configurations for different yard directions. Overall, this research suggests that facade performance is not only determined by the building envelope, but also by the environmental system surrounding it. And that's it. Thank you.
Okay, this was less than 5 minutes. Do we have questions to him? Any questions? No questions. How do you relate this to your climate, to your local climate?
Actually, in my case study is in West Melbourne. So the prevailing wind and the sun exposure is the most important climate conditions here. So I just simulate the house that facing the north side. So the most solar exposure will be in north, because we are in south hemisphere. Yeah. I think that the sun and the wind is the most microclimate factors here.
Okay, there's this question. Come on.
Yes. Thanks, Vali, for the presentation. I have two questions. So first of all, what kind of vegetation do you propose, and how long does it take to grow? So you have like big trees, like on your poster. How, like, yeah.
Yeah, thank you for your question. This simulation was just run for 1 day in a severe hot day in summer, and the vegetation I just modeled as a double height of the buildings. So if here in my model the house was 5 meters, so the tree was 10 meters. And the distance between the trees and the house is in my next stages. I just modeled it and simulated another case scenario. So it will be published in next few months. I just configure in different configuration of tree types, like evergreen or deciduous trees, and in different directions. For example, if this is the north side, I will simulate it in other directions of the related to the facade.
Okay, thank you for the pitch. Hang on. Thanks for joining. What time is it at your place?
It's 9:30.
Okay, that's okay. It's not too mean. When we try to do these online programs, you remember we had difficulties to find the right moments. And it also shows to my two bosses, this is really international. Thank you. Next pitch. Applaus. Next group to present bioregional design and workflow for mycelium composite materials of the built environment. Who's that?
Okay, so hi, I'm Fiamma Marselli from Politecnico di Torino in Italy, and today I will be talking about localizing mycelium practices as an adaptable bioregional design for the built environment. So for most of human history, buildings were deeply connected to their place. They were constructed with local materials adapted to local climates and informed by generational local knowledge. Today, many buildings have become placeless. So they depend on global supply chains, imported technologies, as well as materials that travel thousands of kilometers before reaching construction sites. This follows the linear model that we all know of extract, use, dispose. The environmental consequences, of course, are leading towards resource depletion, biodiversity loss, climate change, and increasing pressure on ecosystems. So my question becomes, so what if, instead of extracting building materials, we could grow them? This is where my research begins. So my work investigates how mycelium-based materials can be developed through bioregional design approach for the built environment. So mycelium, for who doesn't know, is a root-like network of fungi, and when combined with organic substrates, it can act as a natural binder, transforming waste streams into lightweight, biodegradable, compostable composite materials. So most research today focuses on material performance assessment of mycelium composites. My leading question, and kind of the gap that I was able to investigate, is how can we develop mycelium materials that are rooted in local ecological conditions as well as utilize local resources? So to answer this question, I developed an adaptable workflow for localized biofabricated materials based on bioregional design principles. So the workflow begins with material mapping at a regional scale, identifying locally available organic resources, including waste streams, byproducts, as well as virgin biomass. And in parallel, focuses also on harvesting local fungal biodiversity through sampling and isolation of endemic fungal strains. And focuses also on finding local available nutrient sources as identified to support fungal growth, basically. So these bioregional inputs are integrated into a biofabrication process that includes substrate preparation, of course, inoculation, mycelium growth, molding, processing to produce composite materials. And the outcome, the idea, is that it's not a single material recipe, but an open and transferable protocol that can be adapted to different bioregions according to their ecological conditions, as well as available resources and local knowledge. So by shifting to the focus from global material supply chains to actually locally rooted production systems, this approach could have the potential to support circular, decentralized, and regenerative material systems for the built environment. So that is it. I did bring some samples that follow exactly this protocol that I developed by utilizing local resources from the bioregion of Valle d'Aosta, which is in the northern western Alps in Italy, and local fungal strains that were isolated within the lab. And yeah, so these are the...
There's a question.
Yeah.
Of course, Marcel has a question on fungus, of course.
Thank you very much. Very clear presentation. I was wondering, did you already found big differences where the species are from? So regional differences, if you go higher in altitude or more south for the climate, do you see changes in the performance?
The performance is yet to be tested. The idea now is kind of at the early stage of assessing the fact that you can utilize fungal strains that are not the most researched ones in academia, let's say, which are Ganoderma lucidum, Trametis versicolus, Pleurotus. Also because these ones are...
They're always using the same,
yeah.
Of course.
But these are also, for example, patent protected. And so the idea to shift towards different material, different strains that you can find in local bioregions is that then you could potentially not only root them, but also commercialize them in some way, utilizing like bioregional resources, of course. So there are some differences. For example, I did some sampling from Fometis pinicola, I think it was, that I found in Italy and that I found in Denmark. And the differences in the material was the same, like it was pretty much the same in the growth. So in Europe, it's a thing. Then if you change continent, it's another thing because then you have different species. But the idea is to kind of find these species and localize them, yeah.
Thanks.
Thank you.
More questions? Yes. Of course.
As a biologist. Oh, sorry. May I still? So super cool presentation. Thank you. And fungi are cool. So very nice idea and concept. And of course, one of the advantages is that they are biodegradable. Yep. But how do you prevent them from being biodegraded when you don't want them to be biodegraded?
That's a good question, in the sense that you could process them with some like resins or different materials, but the kind of question is, to me, would you use them in an instance where they don't have to be biodegradable, or would you use a different material? Because, of course, these living materials and these growing materials have some limits that we can focus on now and we can research more upon. For example, I'm using it, like the main goal of my research is to do insulation panels, which are technologically sound within a like envelope, and that should be in some way be protected. So the question becomes, should we treat them enough so that they become non-biodegradable? That's kind of like the nuance that you could have when talking about these materials. Yeah. Nice. Thanks. Thank you.
Thank you.
Thank you very much.
Yeah. And this biologist who was just talking, Janine, is actually a manager of the Lifelong Learning Center, which organizes this program. So it's a complete different story. Now, completely different topic, enhancing fire-resistant glazing with borosilicate glass.
Good afternoon, everyone. I'm Stijn, this is Braden, Katie, and Sarah, and we're here to tell you something about borosilicate glass. Borosilicate glass is a different family of glass. It differs from soda lime glass, which is most commonly used in the built environment, because of the additive of borosilicate into the glass itself. Borosilicate glass can most commonly be found in glass oven trays or medical equipment, but not so much in the built environment. There are several reasons for that. One of which is that borosilicate glass is not produced in a float line factory, but only in specialized facilities. And more importantly, there is no recycling infrastructure set up for borosilicate glass. You cannot mix two different types of families of glass, since this will result in cracks and fakeness in the final results. However, what makes borosilicate glass very interesting is its property. It's very low heat expansion coefficient. This means it can handle extreme temperature differences really well, which is why it's most commonly found in glass oven trays. We wanted to push this to the limit and see how borosilicate glass would perform in a wildfire scenario. So in collaboration with Façades and the glass lab here at the TU Delft, we constructed two identical panes of glass, one of which made out of recycled soda lime glass, and one of which made out of recycled borosilicate glass. The panes were identical to each other, 35 by 35 centimeters, and about 1.5 centimeters thick. What we did at Façades, we placed both panes into the oven, after which the oven was turned on to a maximum temperature of 1400 degrees. This temperature was sustained for about 10 minutes. After 7 of those minutes, the soda lime glass spectacularly failed. It melted completely through, while the borosilicate glass remained completely intact. It only bulged out a little bit. What this shows is there's a huge potential for borosilicate glass to be used in the built environment in extreme cases. As I mentioned before, wildfire scenarios are becoming much more prevalent around the world, and borosilicate glass could be a perfect solution to that. There are glazing units available on the market right now which are very resistant to wildfires. However, these are single-use units. They depend on one of either side breaking, after which the interim layer can protect the inside or the outside from the fire. In the case of borosilicate glass, there's only one single pane of glass needed in order to protect either side. We see borosilicate glass as the perfect new candidate to enter the built environment and to solve a problem we face around the globe today. Thank you.
Questions to this? Yeah, of course, of course. This gentleman does a lot with glass.
Thank you very much for your presentation. I'm curious, you choose to have the case study focused on wildfires, opposite to other. In the built environment, there's already a lot of question and usage of fire-resistant glazing. Why did you choose this case, and how does it differ, or why do you need it?
Well, the easy answer is because we follow the extreme course, which handled a wildfire scenario. However, the test we did at Effectis started out as a wildfire scenario. The fire curve of a wildfire is very different to, let's say, an indoor fire, because the fuel gets burned up really fast. So first we did a wildfire test, which went up in temperature really fast and then cooled down very fast within about 5 minutes. After that, we tested a true fire scenario with a constant temperature, which was a lot higher than a wildfire would be for those 10 minutes.
Yeah. So to summarize, the curve of the temperature is different than the built environment, what you normally have as a case study. And what would be your recommendations? So now you have proven it to be suitable for to withstand this curve and remain intact. What would be your recommendation for the next step to bring it towards the system?
I think there are two main steps to be taken, one of which is the setup of the infrastructure to recycle the borosilicate glass. As mentioned before, it's not recycled today because it's produced at such a small scale, which is the second step that needs to be taken, which is to scale up the production of the borosilicate glass. It's not produced in float line factories simply because, well, the additive of the borosilicate float line factories work constantly, so adding in it halfway through the process is difficult.
And just to add one more thing, I think it would be interesting to see how it performs when it's like thinner glass, because of the way that we tested it. It was based off like making them both using cast glass, because we don't have the facilities to make float line glass. So I think testing it thinly and seeing if that performs the same way that it does in this scenario would be really helpful and interesting.
Thank you very much. I don't know if there's more questions.
There's one more. I'll allow one more.
Thank you for the presentation. That's very interesting. I was wondering, it's much related with this development of the infrastructure, which could be quite expensive depending on what are the investments needed. So I was wondering whether cost-wise, were you able to do some kind of a projection or simply thoughts related to the cost of the final products, because then the competing product is something that is extremely expensive. So was wondering some thoughts on this.
No, that is true. And honestly, when we were looking at some of the reasons why borosilicate glass isn't actually used as a replacement for soda lime at the moment is the cost factor. It is more expensive. But when you have to design for like fire reasons, for example, in the UK, they're very careful on fire safety at the moment. So it means that you have to use a panel that's already got 2, 3, 4 panes of glass in it that is soda lime glass. So I guess our equivalent would be like, well, rather than needing extra panes of glass to meet that level, why don't you use a different kind of glass? But again, that would have to be tested. I'm not sure if that would work out, but that would be my pitch for it anyway.
That actually even makes an industry pitch interesting. Thank you. Thank you. Applause.
Thank you very much.
Now we come to WASPER 3DP, free parametric framework for design for additive manufacturing for performative facade components. I have to explain, WASPER is a 3D printing device from North Italy.
Hello everyone, my name is Juan Diego Vargas. I'm a PhD student from Politecnico di Torino. I'm currently visiting the University of Minho. And my research, we know that the building envelope is one of the key building domains, as it has to deal with environmental phenomena like the sun, rain, and wind. And for this reason, the way it reacts to this phenomena is very important because it will affect the user's environmental quality and also the energy needs of buildings. And some of the most critical aspects in how we make facades nowadays is the fragmentation, because first we do geometries, then someone assesses them somehow, and in the end they consider the manufacturing constraints. For this reason, during my research, I have been working on a free framework that's called Wasper 3DP, which is a Grasshopper plugin that helps designers make use of design for additive manufacturing methodologies, where you can have computational design, performance assessment, and fabrication all together in the same interface. So the main idea is not to have like fancy shapes or new materials, which I think is important. The main goal is that we can give like this complexity that is brought with additive manufacturing to an actual purpose. So within a single interface, the user is able to manipulate complex geometries, complex infills, like for example, the triple periodic minimal surfaces, which are being researched a lot nowadays. And the user can also know some morphological aspects that can affect the performance of the elements, like porosity or tortuosity. And then, in this case, like specifically, the user can also use some thermal simulation methods, like some analytical and numerical methods that are embedded in the tool. And in the end, it can prepare it for the actual additive manufacturing. Yeah, so basically, the idea is to leverage like these innovative technologies, and that brings a lot of complexity to the table, so that we can really think about the actual like key performance indicators. Like we can measure the actual properties of this complexity we can achieve thanks to additive manufacturing. And if you, I don't know why everything, okay, it's actually working there. So in the end, if you would like to see a bit more of this framework that is ongoing, please join tomorrow the Food for Rhino webinar. I will be giving at 5 p.m. Central Eastern Time. So thank you very much for having me here, and I'm sorry for the inconvenience of not being able to show the actual presentation I had prepared for this event. But thank you very much.
Okay. Yeah, as you noticed, this was a lot of information, and I have to say, I met this guy last week, and he was giving the same presentation in 20 minutes. So this is a challenge to crunch it together. Questions? Questions to him? Yes, 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 yes.
Thanks for a very interesting presentation. So my question would be, do you really think that through the geometry we can shift facades from being multi-layer materials to be mono materials? Do you think that we can reach that?
I think it's achievable, and actually one of the main aspects of my research is actually validating these methods. Of course, they are limited because for the moment we have been focusing on the steady-state methods, but we're working on validating through some experimentations. So we are making like thermal measurements on some 3D printed samples, like the ones you see here. So here we have a diamond, a triple periodic minimal surface, and also an octahedron. So what we're doing is that we generate different arrays of each topological family, actually 4 of each, and we are comparing the results we're getting from the simulations against the heat flux meter apparatus, so that we can calibrate further the results we're getting from the method we've been developing. But the answer is yes, I do think that we can use material way more efficiently thanks to additive manufacturing.
Yes. Again, can recall it for the digital.
Just don't forget to validate it in the future, maybe not feasible within the research project to the other domains, so fire safety, all the other physics. Yeah.
Physics, structure design.
No, there is so many things missing for sure, and actually that's why in longer presentations I normally frame the scope of my research until the technology readiness number 4, because there is so many things missing still, and there are also, like, facades are not just about heat transfer, there is also moisture and many other like physical phenomena going on, so it's a very complex issue.
Exactly, and the conditions surrounding are not static, so
exactly.
Just that for future thoughts.
Also, yeah, we have to move from the steady state to dynamic state, which is way more complex.
My question is then, right now this is all monolithic, but as we do know, we like windows. So have you considered how we are going to have connections between this monolithic piece and the window piece that is theoretically out of glass or some other sort of transparent material? Have you considered that at all? Is that outside the scope?
It's outside of the scope.
Okay.
Like for the moment, the research is focusing on the development of opaque building systems or subsystems. But of course, if we want to scale it up, we need to think about so many things, not just how to fit the windows, but also how to attach a facade to the building, or is it going to be a facade subsystem? So will it be attached to a different, bigger system? Like, there are so many questions that we still have to answer.
Yeah. Cool.
But thanks.
There's one last one.
Hello, Juan Diego. Thank you very much for the presentation. So the examples that you were showing were mainly related to ceramic materials. Yes. And to a certain kind of advanced manufacturing method. Yes. So I was wondering whether, in terms of methodology and like the script and the workflow you're producing, if you're changing the materials and the advanced manufacturing process, do you see any limitation of the approach that you are doing, or have you already tested it on other kind of advanced manufacturing processes?
Well, we haven't tested, like, it's mainly for additive manufacturing and like liquid deposition modeling, but the process can be scaled to other advanced manufacturing methods, because it's not just about generating the printing pads, it's also about being able to generate the ideal geometries. Like, for example, I know there are like other tools like NTOP, in which you can generate very complex geometries, and then you run simulations on them to assess their performances. So basically, it's the starting point of like a performance-based methodology that can be used to maybe scale up to other advanced manufacturing methods. It's not just 3D printing. And it's completely inside Grasshopper, so you can link it to other existing frameworks or tools that are there.
The interesting thing is, last week you were presenting to 3D printing lovers. This time it's about facade guys. So it's a different story. You get different questions. Thank you. Applause.
Thank you very much.
Lorica.
Good afternoon, everyone, and thank you for the technical support. I'm Giorgia Vercelloni. I'm here to represent, together with my friends and group mates, Team Lorica. We developed this project for the Bucky Lab. We are master students in architecture. And we developed this project with the idea in mind of being inspired by nature. So we decided to develop a shading system that is inspired by the armadillo skin. Our inspiration started in Leiden, in the Naturalis Museum, where we saw for the first time, at least for me, how is actually the skin of an armadillo from a close look. The way it behaves, the flexibility, the transparency that there is, the difference in materiality that we can see. So we wanted to try and emulate this with textile and propose to the market, or to our studio, a new idea for a shading system. So The shading system itself has 3 strong points, in our opinion. The first of all is being able to be configured in very different ways, and thanks to the fact that it's actually made of textile, based on the configuration that you have, you're going to have a more or less shading effect on the interior. So we are more involved towards the idea of having a pleasant experience from the user inside, also because it's testimonied and studied how the presence of nature and a natural element is of great benefit for the human mind and well-being in general. The second element for sure is the easy operability, especially on a small scale. We have 2 cable systems, one responsible for the opening, another one for the closing, and still it tries to emulate also in the dynamics the armadillo skin. Third one, the most important for our course especially, was the biomimicry. So the idea of remembering and recalling the movement and aesthetic of the armadillo, both on a static aspect and a dynamic one. So we tried to imagine how the system could exist inside the urban environment, still going back to the benefit it can have to the mind. So we wanted to see how in a very dense urban environment it could actually behave and merge. So we have some sketches trying to understand a little bit of the idea that it could have given. So to realize this, we stepped a bit into the technical part, and we decided to propose a larger scale model. So it needs to be controlled mechanically, and we have multi-carriage railing systems that are motorized that host both the anchor point responsible for the translation of the textile and the 2 cable systems that are controlled by cable winches that are responsible for the expansion of it. Lastly, what is most important for us, again, is the feeling that our system, our Lorica system, could offer to the interior space. So we realized a small model that could give us this render-like pictures to see actually how the shading is different from a normal shading that you could obtain from a textile system that is, for example, the one that it's hosted in the architecture building right now. So thank you so much for listening to us, and that's it. That's our Lorica.
Oh, again.
It's everything. No, it's everything very, very interesting. So it caused a lot of questions. Thank you for the presentation. And I was wondering if you had any thoughts about one of the aspects that are related to the deployment of external shading, also lightweight ones, which is really their usability connected to high wind loads and whenever you have a little bit more than a certain wind velocity. On that?
Yes, absolutely. One of the next steps, if we wanted to develop this further, is to really understand how to deal with the elements, both rain in terms of which kind of textile should be chosen, also because the market offers a lot, but it's very difficult to understand, especially without being a specialist, which kind of textile could ensure us to satisfy the mechanical properties that we need for the textile to resist the shape and eventually the consumption over time. About wind, it also depends a lot on the building that you're gonna introduce this in, because if you have a continuous system, of course, it's easier to avoid the gallery of wind effect behind it. But it's, of course, a thought to be made and to ask someone else.
This gentleman over there is a facade engineer.
But thank you so much.
A facade teacher, so you may blah, 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 blah.
The question was partly answered in the previous one, but if you would have to do a very short, small pitch to oppose it to standard blinds, what is your most important selling point?
Is the human aspect that we many times forget. The human experience that you can have. It's not just about aesthetic and the attention that you can bring to a building, but also being inside of the building.
Thank you.
This came very, very direct and clear.
I'm curious why the armadillo specifically. Do they use their skin to hide from the sun? Is it deployable in the same fashion? What exactly, other than the shape, inspired this project?
At the beginning, this project was supposed to be a filtering system for the atmosphere. So we imagined that in a very dense city and having pollution and maybe micropollutant possible to be filtered by a textile. But of course, we did not have the chance to try it in this way. So we decided to go towards something that could be more largely used and could be easier for us to understand. So we went towards a shading system. And the idea is to be inspired by this breathing effect also that the armadillo shows when he moves. It's not just the rolling part of it, but it's also the way that the skeleton, it's called armor. The skin of the armadillo, it's called also an armor, and lorica, it's a Latin word that refers to the ancient Roman armors. So this especially.
Thank you. Here we close. Applaus. Take it. Next one to come. Reglass thermal blocks.
Good afternoon, everyone. My name is Maya Dzivok, and I would like to present you some of the findings from my master's thesis, which I conducted here at TU Delft, which focused on transforming glass waste into facade blocks with improved thermal performance. And the reason why I chose glass for my elements is because it's in principle fully recyclable. And here at TU Delft, there was an extensive research on how contaminated glass can be cast into self-standing assemblies, facade assemblies. Their main limitation is poor thermal performance. However, within the same glass family, there's another material, foam glass, which on the other hand has limited structural capacity, but performs perfectly as an insulating material. And as a part of my thesis, I tried to respond to a question: how can foam glass and cast glass be combined into one fully integrated facade component, which responds to modern building envelope requirements, and in particular to the thermal resistance requirement for external walls defined by Dutch building decree. And in order to respond to those needs, I propose a facade assembly from identical facade blocks relying on dry assembly. And each block is composed of layers of solid and foam glass, where the cast glass core provides the mechanical performance and ensures the connection between the elements. The foam glass provides the thermal performance, and finally the external fused glass layer protects the panel from any damage. The circularity of the panel is ensured by the fused connections between the elements, which allow the panel to stay fully glass-based. The most important aspect affecting the thermal performance of such panel is the quality of foam glass. During my study, I tested various combinations of foam glass from different glass waste, and the best performing one was the one made from light bulbs foamed with calcium carbonate. And with the conductivity value that I achieved, the whole panel would need a thickness of 40 centimeters to meet the thermal requirements. And following this section, the panels would then be assembled with an interlayer in between, which accounts for any imperfections, tolerances, and also reduces the stresses between the elements. And the whole system is supported by a steel and aluminum frame, which compress the assembly into full wall. And there are still multiple questions to be answered, in particular in terms of scalability of foam glass, optimization connections between the elements, but the layered assembly also offers the potential to create a solution which can be adapted for different climates and applications, is demountable and fully circular at the end of its life. Thank you for your attention.
Glass bricks, glass bricks, glass bricks, glass bricks. Come on, you have a question. Yeah, of course.
Thank you very much for this research. It's very inspiring. It's nice. Do you think, is there a chance that we can make transparent foam glass at a certain point, or at least opaque? I think you already moved from the ugly black foam glass to your foam glass. You found it's aesthetically already very appealing. But do you think there could be a next step that we could have some opaque light translucency on the horizon?
I think it's very challenging. Some of the colleagues who worked at the same time with me in the laboratory, they tried, but we mostly see an obstacle that it, first of all, has to be very thin, because just thicker assembly usually doesn't allow for any level of translucency, and it's still a challenge. It mostly turns out opaque.
I would say there's a problem by the surface not being flush. So plan parallel transparent glass, and that's an issue. I'd like to have a question as well. Do you really need that piece of solid glass in the middle? I can stand off something like this. It's not going to fail. So I broke it. Okay.
So for the
okay, too much. Come on. You're all going to remember this moment. For sure. I apologize.
There is clearly some limits to the compressive strength of the foam glass, and I believe that to ensure a better compressive strength, it's safer to have the solid component, especially for the interlocking connection. Especially that also the thickness is also hard to control, so it's better if there is some barrier in the middle which divides the panel into two different sections.
I think I just made the mistake of having a point load instead of a serious load. Okay, here we stop. Sorry. Applause. But I really like the topic because it's actually one of the few materials you really can recycle in the mineral environment. Concrete and bricks, not good. Translating residential values into modular facade design.
Okay. Welcome, everyone. Is everything working? Yeah. Well, let me start with the fact that we designed today focusing on a facade focusing on an energy label. But for me, it's also important that you design for the person behind it. So my thesis tries to put the residents into the design process, asking in renovation if the resident could be a co-designer of their own facade. Let me start with sketching the problem, because currently there are two different worlds. The engineer focusing on optimizing the performance, and the resident actually living with the results. But the resident doesn't really see the facade as a technical envelope. She experiences a specific window or a daylight that she gets. So currently, the engineer or the technical world ends up shaping the design, and the resident is left out. So the missing step is value translation. So translating residence values into facade parameters. So with that being said, I created a method where you can create a traceable chain of the residence value you find in a specific engagement method, where you move from values to design indicators to facade criteria to a specific facade component, which you can read both ways, moving in between the human social world and the technical world. So a resident may say, I want a window I can actually open. Yeah, seems fair. Well, okay, then you say, okay, this is more focused on comfort. And then you can say, we focus on a more operable insulated window with user-controlled shading. So this method is then configured into this modular facade system, where you have layer one, which I call the performance baseline, which secures the performance of the building. Everybody gets the same baseline with specific structural frame, insulation, and new window. And then you move to the layer two, which is the fun part, because that's carrying the people, that's adaptive and responding to the different value priorities. So this is the two-layered approach. So layer two is adaptable, I say, but it's not unlimited customization, because there's a bounded component catalog, which is categorized in different value clusters, where you can choose components from, which makes, it's still, it still gives the resident voice, but because it's bounded, it's still buildable at scale, because it's a modular facade. And then the workflow you apply to this method is 4 steps. First you listen, then you translate the values, then you design with this modular facade system, and then you compare it. So that the value you gather with the engagement stays traceable till the design. Then you have the method. This is an example how you can configure it. It's a building in Rotterdam. So the layer 1 secures the performance, but layer 2 shows the different value priorities. So someone living on the top may say, oh, I want more daylight control, which results in comfort. So it's giving her more choice for sun awnings. Well, and then maybe this is a more climate-aware household. Okay, I prioritize sustainability. This can result in vertical greenery. It's all different choices. So coming to my end of the contribution, it's not one facade design, but it's more about the method, creating a traceable chain where you can find the value from the start of the process to the factory, trying to gap these 2 worlds together, because they rarely meet. So that's the ending, designed with, not around, because yes, the room may be experienced warmer, but it's about listening to the people actually living with it, so you can trace it back to what they valued. Thank you very much for your attention, and I'm happy to take questions.
Okay, questions.
Thank you so much. Very interesting approach to facades, but I was wondering what happens with the architectural language. So here you are giving all the power on how the facade is aesthetically, or at least a great deal, to a user. And you showed a very nice image in which all the people that were living in the first floors had same preferences in the top also. And I mean, you could see there was an intention there with a single mind. And here, when you give the power to the users and there is not anymore the role of architect, what would happen? Maybe in Rotterdam, which is eclecticity, could work, but in other environments, not so sure. So what are you going to do with all architects?
So I focus on social housing, that's correct, because the voice of those people are often left out. But to understand your question, are you wondering where the architect is standing in its process, or how you keep the architect's role the same?
Okay, I try to make my question more straightforward.
I want to answer your question.
So what happens with the final architectural language of the building? Because you checked first with the performance in terms of functional performance, then give power to the users to meet their preferences, but there is no one there that is thinking about the cultural context in which this building is placed off, what this building wants to say out itself, all the art design world, which, I mean, I hope this is what architects also deal with, and you didn't put them in the...
Well, yeah. No, actually...
Who thinks on the beauty? Maybe this is the straight question.
It's about wanting to work together, but I put in now a lot of power at the resident side, but I actually try to incorporate this specific neighborhood character, which I called identity as a value. So it is there. So then it's the next step where you can maybe express this in the architectural language, because that's the translation step. But unfortunately, I couldn't do my own engagement method. But then it is interesting to see how these parties work together. But the architect can have some influence by creating that component catalog, because that's influenced by the resident. Yeah, so that's my answer.
Okay, very short last one.
I'm curious, is this image, is this the project in the making, or did somebody die and there's a new inhabitant?
Yeah, this is Mars. I try to, no, this is, oh, sorry, this is future perspective, trying to go, yeah, look at the barriers, how it could look like in a few years. So it's not real life, but it's about different skins on the building. Yeah, and giving residents accountability. Yeah, that's.
But when somebody dies, is it changed or is it?
Oh, sorry, dying. Yeah.
Or is it paint?
A change of person inhabitants.
Oh, that's possible. Yeah. It's adaptable. Okay, dying. That's not fun. But yes, the facade can be changed. Yeah, that's possible. Yeah.
Here we stop. Applause. Thanks.
Yeah.
And I have to say, it's an interesting change. This is building technology, facade education. Talia pointed being the guide. And it's not anymore about bolts and rubber. It's not anymore about money, which was kind of an issue for a while. It's now also about social engineering as a research topic, which is interesting. Next one to come, structural glass notes. Who's that?
Okay. Hello, everyone. I'm Esra Çelker. I'm a PhD candidate in Istanbul Technical University, and today I'm gonna present the output of my master thesis, which is conducted previous years ago. So the question is, the research is how we can increase the transparency ratio of the cable net facades. So according with that, as we know, the cable nets is really high translucency ratio, but can we just make another innovation by just regarding some theoretical background? Every engineer just dreamed that zero waste and the infinite span. So how we can make it? We were just sorting on it. So in order to do that, this is a structural design and architectural design integration. So due to that, we have needed to first design some kind of a test stand for the cable net facade, which is located in Istanbul. This is the FDI Facade Testing Institute, and according to this reinforced concrete shell, we are just making all the details and all the shop drawings, with my sketch in the beginning, of course. And afterwards, we make a finance element analysis to just understand what is the reaction forces which is implied to our structural node. And afterwards, we are just focusing on how we may transform stainless steel clampings and the point fixing nodes into the laminated and tempered glass system and the node. And in that case, only the core of the system, as it's seen over here, stainless steel, but the rest of them is a glass-made node component. Of course, we may do all the structural analysis. As you can see over here, all of them are just seems to safe. And afterwards, according to the results, we are just going into the prototyping process. And in that case, we begin to the 3D printing in the 1:1 scale. And afterwards, we made autoclave processes and all the things. It will be real harsh. And we are just surging on two materials. The one is a silicone-based adhesive, which is between the metal core and the glass parts. And the other one is acrylic-based adhesive. So we are just making some kind of a test. Sorry, there's a video over here. And we are just making a tension test in a independent test facility, and we are just determining their real strength over here. Right now, it's just going to the bricks. Yes, it's something like this. And afterwards, according to the results, which is 5 samples, is just experimented, and the 4 of them are just brick, and 1 of them there's some kind of a bolts for the junction. There's a stripping effect over here, and all the failures is just seeing that the acrylic-based adhesives is much more higher performance if we compare to the silicon-based one. And as you can see over here, the average strength is 8 times higher than the target dimensioning of the glass node. So in that case, there's some kind of a questions, what is the next? I just would like to share with you. And in that case, maybe we can do that a smaller dimension and prototyping. And maybe we are just trying to interlocking joiner design between the stainless steel and the laminated tempered glass parts. And maybe we are just remove the stainless steel and thinking about what is the core is the tempered and laminated. And maybe we can use them as a glass blaster. And it will be really nice to have a full-scale testing as a facade unit. And what about if we are putting a transparent PV photovoltaic systems into this kind of idea? Thank you very much for your listening.
Thank you. And obviously there's questions, and obviously the glass guy has to have a question because you're the glass guy.
Well, thank you. Very interesting. I'm in your scheme. Could you go the slide where you have the 3D layout of your node? Where does the glass panel of the facade sit? Just as a clarifying question. And second, could you briefly explain the load path of the transfer of forces to the cable?
Maybe it will be nice to just go back.
Yeah, that one. Oh, so yeah.
Over here, there's a glass glazing units, and in the middle of the 4 glass glazing units, there's a clamp and a point fixing clamp. And we are mostly seeing in this in the sector and the market over here is a stainless steel. We are just removing all the stainless steel part except the core of the system, like a cross-shaped core. And afterwards, we are putting the cap profile or cap flat part is tempered and laminated, and the rest of them is also tempered laminated. And I just would like to add, this is it seems like for the dimensionally it's a little bit over-designed because there was a limitations about the manufacturing in Turkey. It will be maybe 10 to 10 or 7 to 7 centimeter, but still is the safe for this kind of structure.
So the glass is sitting where the
this gas,
device is. Yeah,
over
thank you.
here.
Yeah.
4 glazing units is just positioned over here. Of course, we need some soft padding elements in between them.
Would you be able to use the same node for single dimension or single cable as well, or do you need a double cable?
I haven't calculated for the single cable. It's a double cabled, and reaction forces is just coming from here, but it will be a really nice idea. Maybe I can also try with that. Thank you.
It's Marktal 2.0. The two of you are going to talk later. More questions? More questions. Did you do testing?
Yeah, for just the glass node, but it will be really nice to having a full-scale testing with the glazing units. I think it's the next part.
And do you have any ideas, us as earthquake specialists, do you have any ideas about earthquake with this system?
Sorry,
do you have any ideas about earthquake with this system, as us, your professor is an earthquake specialist?
We are just exposing the wind load for this system, but it will be really nice at testing the earthquake effect.
Okay, open question.
Yeah.
More questions from the audience? Nope. Okay, thanks. Applause.
Thank you.
And now we have 3 more to go, which are online. And there's the next one, Solar Adaptive and Circular Facade Parametric Design Workflow for Involving Cities.
Hi, everyone. My name is Arlind Dervishai. I'm an architect with experience in Italy and Scandinavia, and I'm completing my PhD at KTH Royal Institute of Technology in Stockholm, in Sweden. And in this presentation, I will present the concept of solar adaptive and circular facade, which is a performance-driven building envelope designed for evolving cities. As cities continue to densify, access to daylight is becoming increasingly a scarce resource. By 2050, nearly 70% of the world's population is expected to live in urban areas, and many areas will continue to grow both vertically and horizontally. So as new buildings appear, they can significantly change solar access and daylight conditions for existing buildings. This raises important questions. So how can we design facades that not only perform well today, but also adapt to future changes while maintaining occupant comfort and supporting circularity? So traditionally, high-performance facades are designed to reduce energy demand and meet regulatory targets. However, facades need to do more than save energy. They need to provide occupant health and well-being, provide access to daylight and visual comfort, and remain resilient to this ever-changing urban landscape. So to address this challenge, we developed a solar adaptive and circular facade concept. The approach integrates solar control principles in a parametric design workflow to create a context-responsive building skin. So using solar radiation analysis, the workflow adjusts the facade properties, such as the window-to-wall ratio or other properties like the glazing frit or the solar heat gain coefficient. So in areas that receive less sunlight, the facade becomes more open to maximize daylight access. In areas that is more highly exposed, the facade becomes more protective, and building integrated photovoltaics can be more used in those areas. And this approach allows also to maintain the facade as the cities evolve without losing the original design identity. So this concept is embedded into a computational design workflow. This is the facade design concept that was integrated there, and that evaluates both performance and adaptability. So here you can see some simulations that inform the distribution of glazing properties in the facade. The result is a building envelope that responds to the solar context, and but adaptation is only part of the story. So then we introduce the solar circularity indicator, or SSI, to evaluate how effectively facade components or modules are maintained, relocated, or used within this building or in the when the urban conditions change. So in the scenario when a new abstracting tower, a 100-meter abstracting tower, was built nearby, the score was 85%, where 79% of the facade, all the facade modules remain unchanged. The remaining part that was altered, changed, 29% could be used within the same facade. Then beyond circularity, the adaptation and circularity is only one part of the story, but also this solution, when we redesigned the facade and made the change, it could deliver 2% more useful daylight, reduce glare, and low overall energy consumption. And then finally, the remaining facade elements that do not need to become waste through digital tracking and future robotic assisted disassembly, they could be reclaimed and used elsewhere within the urban environments. So the key message is that adaptability is circularity, and by designing facades that respond to these changing urban conditions and in future also climate change, we can extend their useful life, reduce waste, and preserve performance. So also creating more resilient and resource efficient cities. Thank you.
Thank you for this online presentation. Questions? Marcel.
Thanks. Why a robot?
That was in the end of the slide, so that's not really part of the research that I have conducted. That's more of part of the vision.
Okay, so I'm happy about that answer. But don't put robots in your presentation when it's not about robots. You're misleading from a very good idea already.
Okay, thanks for the tip.
I can copy that. We had once someone presenting a facade and said, for convincing investors, you have to have robots, and then they love it more. I'm going to ask a very mean question to you. Where is he? This way. This is a super tool integrating everything. What did you miss? What would you add now?
What do I?
And that's the point. It's an infinite problem, and you're adding all bits and pieces. And yes, we're used to structure and building physics, and now we learn to deal with human interaction.
I've sort of, so part of, we have a lot of advanced facade solutions and active control systems and adaptive facades. So this is not an adaptive facade solution, to make it clear. And what this does is that sort of, it's also a solution that how can we design sort of better buildings for humans and sort of a human-centered circularity, not just about building performance and reducing waste, but also putting the focus on human health and well-being. And those active systems and advanced technologies, they're all good, but we don't have a certainty that in the future we'll have those same manufacturers, will be able to control them in an advanced way, and they've always exceeded their costs, like the famous Abu Dhabi facade towers. So in this sense, this is a a solution that can be attainable with what we have today and can be managed in the future when in 30 years the facade needs to be renovated, refurbished, and also adapted to changes in the local context. And of course, we have the technologies like BIM and OpenBIM, and to be able to use and reuse what we have, the workflows, but also the building models. In 30 years, it's what we use today to build. So these are some of the thoughts to your suggestion, but please feel free to ask any mean question.
There comes a mean question, somewhere at the back. Isabel, come on, a mean one.
Maybe it's just a little mean. Who owns the information? Because often the problem is that someone who designs it may not want to share all the information, but if 30 years later someone else wants to change something, it's often not so easy to get the right information. So how do you imagine that to work out?
Well, you have a fair point. So we sort of need to understand where we are as an industry nowadays, because we always talk about having more open information and more open data, and in reality, I've actually addressed that in the research. I wrote something very short. There was a paper of maybe 15 years ago, and how are we sharing information and who owns it? Not my research, but some other researchers have wrote about it for building energy models. And it would be interesting to see today who is managing and owning that. And it usually should be the building owner or contractor that holds that. And sometimes clients ask for BIM or for native files, even if they have no use of it, if they don't know what to use of it. So we have the cases of why we need to use the models, and we need to more open data approaches in the construction industry. So we definitely should move towards it. Who owns it? Maybe it's collaborative, maybe it's blockchain. There could be many answers, but we have to find a common ground. Or maybe it's a case-by-case basis. There could be many
I'm getting
answers
signals that we need to be fast. I give you the last chance for a very, very short one with a short answer.
Okay, thanks for the presentation. I'm going to ask a question that was asked to me 1 week ago, and is how does your workflow differ from what we already have? Because like I've seen already workflows that connect a lot of different tools for facade development. So what's like the difference between the one you're structuring and like what's the state of the art in this matter?
Yes, thank you for the question.
Answer.
So yeah, so there's many different facade control principle or facade design concepts out there, and or using some attractor algorithm in Grasshopper. And what I have not seen is a facade concept playing with the window-to-wall ratio or the glazing properties, not applied to the whole facade and not applied to circularity. So I actually looked at that when I wrote the research, and if you find another one that has done it, please share it, because I have not found it. And I have like more than 100 references in the paper.
Okay, here I stop. Applause. Robert is not getting a question right now. Evapora, also an online presentation, evaporating cooling facade using porous materials. Luckily online, nothing I can stand on.
Good afternoon, everyone. We are master's student from Politecnico di Milano and team Evapora, here to present a facade system designed to close the performance gap in the building envelope industry. The building facades today fail on 3 fronts mainly: compromise on human comfort through poor ventilation, compromise on daylighting, force over reliance on mechanical systems, and often high embodied carbon and non-recyclable materials. Evapora attempts to address all 3. Our response draws on an ancient principle of evaporative cooling. As global warming intensifies urban heat island effect, we need low energy and low emission systems. By using porous materials that absorb water and release cool air through evaporation, we can passively cool buildings, particularly in hot and arid climates. To achieve this, we followed an iterative design process, after which we evaluate these different design modules across relevant parameters. This matrix in the end led us to our final concept. The final selected module is a simple rectangular geometry. A longitudinal groove on the surface acts as a water channel, distributing water flow uniformly across modules. Internal voids reduce weight, increase evaporative surface area, and airflow and allow airflow. The result is a permeable facade layer balancing cooling, solar shading, and daylight. It is modular, dry installed, and easily replaceable.
In order to design the bricks, we ran a genetic optimization, have strained the maximum weight of the brick, and having as an objective to maximize the UDI inside the test room. In the next slide, we find the results. We see how the UDI increased from 40%. There is neglected applying the shading system in all orientations. In the next slide, we see the results in a heat map way. We see how the shading system provides a more reddish value, so the percentage of hours between the UDI is higher, so we consider the daylight performance checked. While in the next slide, we see the composition of them. We have two types, as Michael explained. The brick end on a substrate of stainless steel composed by Manson and Tramsons, and the two channels for water and air in order to do the evaporative cooling. In the next slide, we see. Next slide, please. Okay, we see the water management system. The water flows down by gravity and then is collected on the bottom and recirculated on top by a pump. Then is collected on the top and the tank keeps the water there. Then we see that the facade incorporates both low embodied carbon and lowers the operational carbon of the building while keeping a good daylight performances. And this is a good integrated and holistic approach in order to solve problems of today. Thanks for your attention.
Thank you. Questions to this? Yeah, there's a question.
Thank you very much for your presentation. If I understood correctly, this is your facade solution is working as a cladding, right? It's not a full facade, or it is actually a full facade, and therefore this is the main barrier between indoors and outdoors.
It is technically a second facade layer that you can apply to an existing facade system, especially where you have a fully glazed system, but you would want some sort of shading element for better daylighting and to reduce the amount of glare and the excessive thermal radiation. One would use this kind of facade system, basically.
And so my second follow-up question is, what would be the ideal first skin facade for your system to work at its best?
It would be ideal to have an openable system, whether it's a glazing or not, but we would, as we saw in the previous slides, that it works based on the principle of evaporative cooling, and the voids inside basically allows for a better airflow. So we would need a facade system that would allow the user to open and close so that we can have this kind of airflow for a more efficient performance.
Next question.
Thank you. If I understand it correctly, you want to let water run through because it accumulates heat in the sun. It's an external blinding system, to call it in that way. It's a second skin, and it cools down by being sprinkled with water. Do you have an idea of the amount of water that you need to evaporate in order to compensate for the heat gains by solar shading? Do you have a metric on how much cooling you want to get and how much water it represents? Maybe that's a difficult question, but...
We did a very preliminary study when we were developing this project. So for a facade of 1 by 1 meter square, we would require about 16 liters of water. And that would reduce the temperature.
A day or over what time metric?
Over in 1 day. And if I remember correctly, the temperature difference from outside to inside would be about 2 to 4 degrees Celsius. We also felt that the result could be better optimized as we dwell further in the research, but that is what we, yeah, that is what our initial research led us to.
Hello, thanks for the presentation. I have like some curiosity about your project, and is if you've thought of the limitations and like maybe possible problems you could have with this kind of facade. Also, if you have thought of the kind of environment and like context that they could be used in, because as from what you just said, there's like a lot of water you need for the facade to work, but then maybe this kind of facade, you can use it in weathers that are kind of arid and with low relative humidity overall. So where do you get the water from as well? Thanks.
Okay, that's a great question, honestly. And I think that is something that we discussed while we were developing the project. And we realized that in a place where the system would work best, as you suggested, is hot and arid. At the same time, there would be water scarcity. So we thought as a next phase of the project development, we could integrate some methods of water harvesting where we would harvest a certain amount of water and we would use that water for cooling instead of using fresh water, so that would take care of the water needs. But again, that is very context specific, let's say, and probably we need to look into it further.
Okay, here stop. Thank you. Applaus.
Thank you.
And we come to the last group, Growing Facade, also online.
Good afternoon, everyone. I'm Matteo Baudin, a bachelor student from EPFL, and I participated into the OpenFace education program where I could think about this concept and develop it. I call it the growing facade. What if a facade could grow its own panels and then store its own energy through its lifetime? During the last course of the OpenFace education program about innovation for facade engineering, this question came to me. Could we improve certain very light bio-based materials by giving them energy storage properties and integrate them into a circular and adaptive facade system? The solution? The growing facade, as I call it. A ventilated silicon skin facade with modular mycelium panel on a timber structure. This panel grows on a substrate made from agricultural waste, hemp chives, or gypsum, very suitable for the Netherlands and the Dutch context in general. And added to this, we use phase change materials encapsulated into the substrate before the mycelium grows, allowing the PCM to spread evenly through the panel. Rubitherm 22 was selected because it achieved a phase change temperature of between 18 and 22 degrees, which fits well with European environmental conditions and helps optimize charging scenarios. But then the question is, how do we tailor the behavior of the PCM to the occupant needs and the building use? It's where the control activation comes with the double skin facade. The point is to use an adaptive double skin facade to open and close different vents to manage and enhance the PCM charge and discharge cycles through convection and radiative heat. It can also help controlling overheating in summer and night cooling through environmental triggered ventilation mode. We can also later in the stage include occupant behavior actuators that could tailor specific requirements for different rooms. In general, conceived as a circular and energy efficient panel, they reduce embodied carbon in the building and during its operation, as well as cooling and heating needs. Driven by bioregional potential and biodegradability of mycelium, facade panel could create synergies across the region and become an innovative economic driver for the facade as a system market because they can generate bioregional return on investment. Facade contractors in this system can help grow the materials and then bringing this back into the loop into their own facade product. In doing so, they could provide additional ownership value through the life cycle and make the facade more sustainable. However, as I developed this concept for the OpenFace education project, it's still at a very early technological readiness level, mostly 1 or 2, so early concept and starting of small prototyping, but not a coherent prototype. Further studies should be carried out of the performance of the PCM itself in relation to mycelium, the performance of mycelium growth with the PCM integrated, life cycle analysis, end of life of PCM in mycelium. Because the main challenge right now is, can we fully decompose or biodegrade the 2 different components at the end of life, which could lead to very interesting future product development. And at the end, some reference of the preliminaries study about this topic. Thank you.
The question is, would you spend your grandma's money into this company?
My grandma's company, my grandma's money? Not sure.
Ooh, that's the wrong answer.
I need to ask her. I need to ask her first. That's the main challenge. I need to ask her. She needs to understand, and then maybe.
Okay, I have a question. Very interesting presentation. My question is related to the natural state of the mycelium once it is in the facade. So is it like an inert? Like, do you denaturalize the mycelium, or does it keep growing? Like, I didn't really understand. And if so, would you take into consideration the fact that these could then potentially become molds and develop contamination, and that could also be dangerous for users because not all molds are good. Yeah. So yeah, that's kind of the question.
For this specific product, I actually also during the research looked into the potential hazard of letting it grow, and I've decided to stay on the pasteurization method. So it would be inert at the end, mostly, if I understood correctly, and then be only used as a panel and biodegrade at the end, because it was the easiest way to keep it functional also in a double skin facade. It was the combination of the double skin facade and the mycelium panels.
Actually, it's a subtype tombe wall as a double skin facade, which we see here. And the mold question would actually also have been a nice one for the previous group, which is an issue. We stop here. Thank you. Applaus, yeah, please. So thanks to all who presented online. Thanks to all who came here long distances to present in person. It was really an international program, as we saw. Someone from Australia. I also got the comment that there was a nice comment in the web, in the browser about, you want to read it?
Me? Yes, Pietro says he's from southern part of Brazil near Argentina border, and he says that this subject is not taken serious as it must be in his country. And thank you all for the opportunity to watch it, and he watches it with his friends.
Thank you. We do have a Chilean colleague here who just appeared and did his PhD with us. So there's, I disagree that this is not taken serious in South America. And actually, Argentina is also having an intensive facade industry. So yes, this is what we do, international education. It's a pause now. You're supposed to take a coffee. You're supposed to take it with the same cup as before because we have limited amount of cups. The jury will go for deliberation. We're going to be back in 30 minutes, maximum. Yeah. Oh yeah, and then audience has to be digital as well. And now you may applaud and take a coffee. We made a decision, but we're not going to tell you now. First, you have to witness a presentation of the program, why we are here, Alessandra and Marcel. Shall I take the camera and take some pictures of you?
You know, it's a difficult one. You have to focus here at the back of the...
Okay.
And it doesn't click.
I know exactly that he's going to yawl against me tonight.
There's only unsharp pictures from me.
That's the point.
I actually don't exist. I'm the guy behind the camera usually. Alessandra, what are we up to?
So, welcome everyone. In this talk, we're going to now describe what is OpenFace. You might be wondering what is OpenFace, why we're here, or maybe you've been one of our learners. So, we have a presentation. We should put it.
Yeah, do we have to? No, this is already something is prepared. It's actually an honor and a pleasure to have a multimedia team here who takes care of everything. But we didn't have the time to organize who's doing what exactly. But that looks already good. There's a presentation somewhere. PowerPoint. Oh, here we go.
So, welcome to OpenFace. As many of you know, this is our open education program supported by the Erasmus Plus and the Extension School. And this is a collaboration with Eurac Research and Darmstadt University and TU Delft. We started officially in the OpenFace program 2 years ago, but the idea actually, and the first MOOC is much older than that. And this is our last year, and this is why we decided to do an inaugural final event for celebrating our learners and all the people that have been involved in our course. So we call OpenFace Edu Entertainment because we have tried at our best to put together material and educational content that is also fun to watch. So what is OpenFace? It's a series of MOOCs on one hand. So there are 7 different MOOCs, massive online open courses that you can follow in edX and has been curated by the full team of OpenFace. But it's also a MicroMaster, which is what we want to celebrate today, because today is the official launch of the MicroMaster, and we will tell you a bit more of this in a moment. And more interestingly, for many of you that are teachers or educators or don't have the time to follow a full MOOC, but are still interested in knowing something in a nutshell, OpenFace is a collection of open educational material. These are videos, handouts. You can watch them, read them anytime you want. This, therefore, makes this program extremely flexible. Who are the people behind OpenFace? So we are a team that you can see in the screen from TU Darmstadt, TU Delft, and Eurac Research. You may recognize some familiar faces in this room. And how it started, as I said, is a much older story, and Marcel will go through it.
Maybe we need that one slide. Okay, no, here, perfect. So actually, it was an idea of Uli and myself. Uli wanted to have a video channel. Marcel, my kids all looking at YouTube. We need to go into that sort of medium in order to educate our students. If everyone is on YouTube and they're watching YouTubes for hours, I want to make sure that our content also is shared with them. So skip the university, let's make our content available for everyone on YouTube. They watch it like Netflix. And then Uli ran around and asked many people, and they all liked the idea, but no one wanted to pay for it. So you, traveling around the world with a camper van, sharing your facade ideas, why should we pay? Because everyone has to see it. And then they mentioned, you should talk to the media center, online learning, MOOCs. And then Bea was sitting in front of us. And she said, what, you just want to make YouTube videos? No, we make it into an educational program where the videos just engage, and then there's learning behind. There's a community on a platform where there's peer-to-peer. Okay, let's do that. And it took us a while to get into that. And Tatjana, also being here, she took most of that organizational, educational program and let us loose on the camper van. And we started making this storyboard where Uli and I are sitting in a camper van, driving somewhere, jumping out of it, meeting or going to a building, meeting someone within our European Facade network and friends who actually know all about the various topics we would like to present. And then there's Uli fiddling around and always poking with a screwdriver to get into some sort of a ceiling or whatsoever, or break something, a skill he showed today at perfection. And then we explain something, and then at the very end, I jump into the van again, changing from cameraman to co-driver. And that's what we did. First time, yellow number plate in the front of the Darmstadt campus. Half an hour later, the janitor arrived. So there's no free camping here. I said, Uli Knaak, I'm a professor here. So what? But the camper can't stay here. We had that way often in the city center of Munich on the campus. Coming with a Dutch camper van was quite a thing. And then you can see us already in front of here, Luzern, Bozen, huge company with glass, and that's what we did. That was the very first. And back then we didn't thought that this was a start. We were happy, and we got exceptional good critics for that, and everyone said, hey, you have to do more of that. And then Alessandra and Uli teamed up and wrote a proposal for OpenFace. 3 universities or 3 institutes, and then at the very end, we got it, approval. And that's where we started. We sit together, and we thought, while the first one with the camper van was the crazy overview to get everyone interested in building physics, structural calculations, and all the parameters you can drive around, discuss about facades, then we came up with this course, which we ended up in 6 new courses we had to develop, and I'd like to share them here. Facade design and engineering, complexity made simple, that's the one with the camper van. And then we do the more basic stuff, principles, materials, and technologies of the facade. Detailing stick system, 2 crazy guys sitting on a chair, on a table, overlooking a bunch of details and drawing from hand all these. And then we have a second row, facade theory and technology 2, a bunch of lectures, more going into the depths. Then we have another detailing course, how to detail, most likely, ventilated facades. Then a very urgent topic, circularity. We have seen very nice projects always going to sponsors we are also very thankful for, but we also will mention them later. For instance, standing on a very big pile of broken glass was quite a thing. And the very last one, Facade Forward. In principle, what we did also today with the Innovation Award, because we have asked all of our colleagues and friends within the network to share their latest technologies, their innovations, the drivers that pushes us out of our comfort zone to rethink about cladding, about materials, about facades in general. And this was kind of like a newsroom thing. So there were Nathan and sitting over there also, kind of like becoming the anchorman of that Facade Forward show. And this is an insight in the detailing stick system. So Uli and I, sitting together with experts here, Lisa Ramek, what is a detail? Why do we need that? And this is modules, you can also say week. So we have the introduction, then we talk about the stick system technology. Then we went to a facade provider, in this case Schüco, into their showroom and fiddled around. Talk about various materials, wood, steel, for instance, aluminium. And then we start defining the project we were working on. A big hole in a concrete wall, for instance. And then we start defining the grid. In module 2, we came further and further. We talked about movements and tolerances, final layout, and the selection of the details. And then we go step by step through the various details. Horizontal section, vertical section, left one, right one, above the door, underneath the door. How do you make these all happen? And at the very end, we also went to experts and got their feedback, as we would have been the architects starting to design. And then we go to the structural engineer and said, have you thought about the wind? This has to be changed, movement of the beams up and down. And then we went to Alessandra, being the expert in building physics. Acoustics, sun glare, sunshade, overheating. So we had to revisit our details, put everything inside. And at the very end, we came up with a final set of drawing. So within 6 weeks, you become familiar with all the facade designing. And unfortunately, we didn't find any company who would love to share their mistakes on the building site, so we had to do this ourselves. Because Uli and I, back then, already made the extension of his house using a wooden post and beam facade, and we shared our mistakes we did over there, because none of the companies were open to share their mistakes. And Alessandra?
Some examples of the activities that take place during a MOOC. So this is the activities that you experience if you join the full learning experience through the edX. So the students, especially in the first run of each of the MOOCs, gets also the chance to meet the teachers one-to-one, online, through webinars. In the webinars, we go through the exercise together and we answer Q&A from the students, and we also discuss much broader and larger topics that emerge from student questions on the topics of the MOOCs. This is another example where we looked at, also we asked the students to bring real case studies of facades that are around them. This is the facade of the Rotterdam Central Station. Each week or every 2 weeks, depending on the content, we also give them assignment. The assignments are corrected by us, by the teacher team and the student assistants, but also teaching assistants, but also there is a peer-to-peer learning experience because the assignments are in a sort of a blog setup where also the other students can comment and discuss together each other work. And this also is a nice way to create an online peer-to-peer learning community. This is another example before we look at an example of regarding detail, but we also do this for structures, for instance. You see here simple structural design evaluation of on the structural principle of a facade. And also in the videos, we curated a number of external guests and visits. So we went also to other experts beyond the team of the institutions that are they've created OpenFace to ask other questions and get also broader and more international expertise. This, for instance, was our visit at Polytechnic of Milano. Similar, thanks to the fact that Eurac is also one of OpenFace partners, we interview researchers at Eurac Research and visit all the laboratories they have to test and assess performance of facade components. And similarly, Polytechnic of Torino, you might recognize some faces here, where we visited the labs, but also had a deeper discussion on the luminous efficacy and the relationship between TVs and G-value. These are just snapshots of the type of material you can see in the course. So we go from the very basic principles to much more in-depth content around all the topics in relation to facade design and materials, technologies, performance, detailing, circularity, and innovation. And this is another very nice example that was mentioned before in the, I think it was for circularity, where we visited a glass manufacturing and recycling site.
Yeah, this is also part of it.
And this is also a very nice example of another video that you will find in the Circularity MOOC, where we looked at how to reuse DGU. So all this material is available in openface.org. This website, it's open. You can access all the videos for each MOOC. And you can also find the direct link to the edX course if you want a full learning experience. This is the website. So if you go to online courses, you will find each of the courses Marcel just described, and each of these courses also has the material indexed.
What's very important is that you can join as a student, as a learner, the courses via edX. That's the entire educational experience.
Here you have the full learning experience, the assignments, the webinars.
But also on openface.world, we give learners, other professors and teachers the opportunity to use also our stuff. Because that was also part of our project that we make this also available. So whenever you as a teacher, wherever you teach, would like to use this, you can also do that by yourself, by either using a few or also using an entire bunch of it. So therefore, this is also what we have to share, that the university or the universities all around the world can also use our content.
And from today, we launch also the MicroMaster. And the idea behind the MicroMaster is that if you have completed the full 7
all
MOOCs,
seven
all
with
the
a
7
certificate,
MOOCs, you can get a MicroMaster certificate. And this is officially recognized by TU Delft and TU Darmstadt and has a value of 10 ECTS for our institutions. So if then the student or the learner that is joining and obtaining a MicroMaster certificate gets the MicroMaster certificate, gets recognized these 10 ECTS.
What does it mean? So you can enroll after finishing all the 7 MOOCs. You can enroll for maybe the next slide. This is what we already mentioned. And then we have a final exam, and that is on the next slide. There is
Then I will back.
Back one more, yeah. So then you can enroll yourself to the exam. And the exam is actually a oral exam. And I would like to highlight right now the code. So up to now, till the 30th of June, we have a 30% discount from edX. Get the code TAKE30 off FedEx 26. And you're already able to get this for a 30% discount. For all the learners, and I think we have already met a couple of weeks ago, we met one in London who already followed all the 7 courses. And I think also one of the persons who presented online today has already finished all the 7. So please feel invited, get a 30% discount of the final exam. How would the exam look like?
So it's an oral examination where the teachers, in particular, I think it's going to be first led by TU Delft. So it's going to be Ulrich, Knack, myself, and Marcel. We will go through all the topics and the content that was explained and taught in the previous MOOCs, and evaluate and check that the content has been correctly learned and the learner is effectively ready for having a MicroMaster in facade design engineering.
Just to make sure no one is really, what do they expect from us? So we will ask the learners to bring a design, a facade design they may have done by themselves during the courses, or they may have done within the office. And we will talk about the various aspects of that design to make sure that he really is or she is really into that topic. So to make sure that you understand the different little details about choosing the right system based on the logistics of the building site and the climate that has an influence on the coating of the glass or whatsoever. So it's really not a questionnaire in which we try to unveil if you have followed each of the different courses and have still remembered that, but we want to make sure that you have become an expert in order to judge various decisions based on an actual project.
So who are our learners? Up to now, we actually managed to reach a very large different number of countries. You can see here in a map per density of color the majority of learners are. In particular, this was for a specific MOOC. So what we also saw that depending on the topic, the geographical distribution changes. So some countries are more prevalent for circularity, some other for principle and materials, and this really reflects the access to facade design engineering education that exists in the world, in the sense that depending on the topic, you can clearly see where there is already some bachelor or master education in facades, and therefore only the more advanced topics are appealing, or where, for instance, the more generic and basics principles are also needed. And this is also the reason why back then, when we started this initiative, we wanted to foster as much as possible open education, so that facade design engineering could reach everywhere, any person interested in the world, regardless of the country of origin. And actually, we managed to get, up to now, 14,479 learners with our MOOCs. Of course, the older MOOC is the one that has the highest numbers, because it's also the one that has been longer around. But we see growing numbers for all the MOOCs that have been launched in the last, basically, 20 months.
And just for today, we are happy to announce that we have all 7 courses online available. So therefore, you can start from tomorrow if you like, and pick one of those or the entire series.
I think this is it from all of us.
This is it from our side, precisely.
So,
Feel free to join.
To recap, you can join OpenFace as a learner to have a full learning experience in edX. You can join OpenFace as a teacher to pick, mix and match the content that you need for your course. And please also, if you have ideas to how to expand and you want to join the OpenFace community, this is an open community, so we'll be also curious to see what type of topics we can integrate. So hope to see you in the OpenFace digital environment. Thank you.
Yeah, we have a question from our live stream. How long will the final oral
exam B?
2.5 hours. No, I don't think so.
No.
Isn't it only 2.5 hours? Come on, we have to squeeze everything out of them.
We make it the English PhD exam thing, which is 1 day with 2 people in the room. No, it's going to be an hour maximum. It's going to be an hour maximum. Yeah. And it's either Marcel, Alessandra, or me. 2 of us are going to be present. And as Marcel said, it's not about tweaking you on every detail, having everything seen, but well, we saw today the complexity of facades, and we saw these design tools for facades, and it's actually infinite complex. So the main reason is not that you know everything, but that you know why you make what decision. And that's what this is for me pretty much about. You need to understand why you make which decision. And we'd like to see that with your own details, so that you show how the detail is, and we're going to ask, why is this not fire secure? And you may have to have an argument for that.
For those who have actually done the things you present, it will be a very pleasant meeting and a good conversation about facades, I assume.
And is online?
Online. Yeah, actually made a lot of experience with online meetings, and it's super interesting. Sometimes we have a program when you start somewhere in the eastern part of the world in the morning, and they have sun rising. And at 8 o'clock at our time, you're still in these meetings, but you're at the western part of the world, and they still have sun rising. And you see the sun coming in the rooms. It's really interesting. So that is going to be online. Of course, the whole program is online. And yes, we can announce that we are allowed to have the ones which are participating in our civil engineering program in Darmstadt being able to sign in for this course and replacing some of the 2 courses I do on campus. And yes, we have a kind of a feeling that it's going to work in the same way in Delft. Actually, you talk to the dean and head of department, so there's going to be enough energy to make that secure as well. This is a small side note, so some students may take this as an alternative course. That's all.
Perfect.
Okay, that's
it.
A question? Oh, you wanted to applause. Yes, you may applause. Please do.
But only now, everyone is waiting online. Also, I heard, who are the winners?
No. First,
not.
First, Marcel wanted me to take pictures, but he's standing here. So, Marcel, is this a good point to take a picture from you?
From me?
Yes. What's my problem when you would take a picture of me here in this situation? The light.
The light, yeah.
Yeah, damn, backlight, both sides.
No, but I made you with a lovely glow around.
Yeah. Okay, stop. The winners. First, obviously this is a tough decision. It's always how it is, and there's always some kind of discussion, and then there are always some argues left and right. First thing, which was clearly addressed by our education manager, is we want all of this being somewhere in the program. And luckily, we have this program innovation, so Façade Forward, which is designed to have some principal lectures about how innovation happens, and then a bunch of lectures which are on topics. And we are easily able to add these kind of innovations in there. So we'd like to have from you who did these programs video material, and yes, you can do that with your smartphone. That works as video material, which can then be edited, and we need to identify how we do that and how we brand it, but we'd like to get all these 11 projects somehow in the program. So please feel free to sit again as group, do some kind of fancy thing, and the more fancy it is, the more people is going to look at it. So don't make it serious, don't make it solid, make it fancy. It's an innovation. So all these videos have to be, Bea, thanks for this. All these videos have to be addressed. We want this material, you need to send it to us, and then we're going to edit it and put it into the Façade Forward program. 3 prizes. Out of the box, integrated design, climate and circularity. You count 4. So we started adding 1, which is a wild card. I will come to that in a minute. The very first one, integrated design. Is everybody online as well available? Here we go, integrated design. You remember it, last presentation, growing mycelium and PCM facade for energy storage. Bernudio Matteo. That's the guy who's from EPFL. EPFL, was it EPFL?
Yeah, I would say into the camera. Alessandra, we have to, the camera crew, we have to make sure you put...
Okay, yes, we're giving an online award.
Take this, the camera will catch you, and we will share the pictures of you with the prize.
Is super analog, it's
to the world.
Can you see us? Is he online? He's not online. No.
The news will reach him.
He's a geek. He's into this program since the beginning. He was even in one of the presentation, in one of the pictures in the presentation. I think we also witnessed him in one of these.
Yes, we did.
Online sessions. He's a geek. He wants it.
He also deserves it.
And he deserves it. And you can imagine it's, yes, please, applause. Thank you. Okay, Matteo, this is your place. You place it here, there it goes. And you also can imagine it's not a simple one to make a distinction between a master student who's in the process, a group project which is in the process, and someone who's as a PhD already super deep into. So the out of the box, Juan Diego Vázquez. And he did not expect it because, which I didn't say public, but I may now do because he's happy getting a prize. Last week he was presenting in Darmstadt in this 3D printing environment, and I didn't get it. And I felt like, come on, another 3D guy who's doing another computational. And I talked to my two colleagues which are guiding him, and I said, come on. And they said, no, he's a genius.
So we just have to cut here. Can we rearrange the handing over of the...
Yeah, come here.
We will just cut, and we will later notice that. That's how we make our...
Come. Exactly, you have to smile. I'm going to keep this. You have to smile. You have to shake the hand. Yes, please. Thank you. This is what we want. This is all for social media. We need all this for social media, so get some kind of tilted pictures. You're very welcome. Yeah. Oh, yeah. Okay. Climate and circularity. By law, we are energy neutral 2050. You're aware, huh? European Union 2050, energy is not an issue anymore, so we are by law, because we talked about glass foam being super energy efficient. There she is. And when we were discussing it, yeah, okay, social media photo. Yeah, here we go. Thanks, Marcel. Thanks. And one without. I need to. No, don't run away. I need to comment to it. Robert was very clear by saying glass foam is actually not energy efficient because it takes a lot of energy. You boil it to 1200 degree. How did you boil it to 1200 degree?
So actually, I used recycled cullet, so I foamed it at 800 degrees.
Okay, good. One step, because it's recycled. But as I said, if say energy is not an issue anymore, the material becomes an issue. And I really copy. This is the only mineral-based material you can really recycle next to clay, which is a complete different performance. I wouldn't be able to stand on. Thank you. Okay, free prices. That's what we said, free prices. And then we had this intensive discussion in the group. But what about beauty? And then there was this one presentation which was done so perfectly. So we ended up with a wildcard prize for this one, and I see people agreeing on this. And now again for social media, the whole group needs to come here. You're very welcome. No. Yeah. The mock-up. Oh, you're worried to break it, huh? Oh, yeah. Okay. Take the other one. Yeah, take the other one. All at Marcel. Thank you. Marcel, can you say something about the prize itself?
Yes. Upstream Awards. Actually, Caspar van der Meer and a couple of colleagues of him from the Better Future Factory are already very good in recycling plastics. And Caspar was a mate of mine. He joined the Bucky Lab as a docent. I was actually his docent when he graduated in the roll-up cardboard house. And then he became a docent, and he was also always fascinated by recycling plastics. And a year ago, or 1.5 years ago, they started the company Upstream Awards. Awards made out of recycled material. They now have the prestigious, they made the prestigious Circularity Award, which is handed over by the Queen every year. And they have a lot of more prizes, and all with a story. And this is their starter award, let's say, off the shelf we got, which is made out of recycled plastic in a way that looks beautiful and mesmerizing. And we thought about this is a wave of water crystallized, somehow solidified, and that is the perfect picture, what we would like to teach also by being inspired by using leftover materials, using recycled materials, and
No, Marcel.
we have to support these guys.
Finish it, tell the story about the company which didn't work.
Yeah, they also made recycled filaments out of fridges and PET bottles. That was a nice fuck-up, as we have learned on a fuck-up meeting, where he was actually presenting while 10 years ago that idea didn't went well. But right now, Upstream Awards, a very nice company and good ideas, and we'd like to support them. So whoever needs an award, have a look at them.
Lesson learned, just do. Okay. I'm closing the session. Yeah, of course. So, first, to my colleagues in academia, you saw this program as it is. We were driving with the camper van, interviewing you at your place, making fun of this, and it ended up in being such a program, which was really also impressive journey for us. And Alessandra and me decided we go for a second go, which we're going to call which we're announcing here, OpenFace 2.0. So, dear academic friend, as we are now having this BEA association, and this is a tool, we'd like to do more. So, please address to us if you're interested, and we somehow fiddle you in. And then Alessandra with her golden finger writing all these proposals is going to be the one. Well, she's successful in that. Thanks to Erasmus Plus, which is the proposal we got, which is the biggest part of the money. Thanks for the lifelong learning, long life learning. Learning for Life Center, they changed their brand recently. Learning for Life Center of the University, Janine Kier here, Roberta de Franco and Bea de los Arros Fernandez. Oh my God, German tongue. They were the ones which are really providing us all these tools and instruments and guiding us through the processes and taking care of the numbers and make sure that this works with edX and give us warnings when edX does come kind of weird things and allow us to do all this kind of additional things. Marcel was referring to our early meetings, and well, I'm going to say something in a minute. Thanks to the sponsors, Schüco, Janssen, Bicona, Fibrobeton, and AGC. This is what you need to do as well. And I have to say, the amount of money which came to get that whole program done is the biggest ever amount of money in education, pumped in education by university. I haven't seen it at a different place. It's, say, at the higher 6 digits level. That's a lot of money. Thanks to Alessandra Navarro. Luna Navarro. I like it. Thanks to Isabel. Here we go. She's also arguing always to me. Bernadette is not here, who's another partner from Darmstadt, Marcel Bilo. You meant Miriam, where is she? There she is. Miriam, also from Darmstadt, not here. Tatjana left us, sadly. Me, of course. Thanks to we called it educational assistants. That was the official wording which we gave. Yeah, which are actually students. So students like you, which are in the middle of their studies, impressive. Where's Annabelle? Annabelle was the very first one when we were really trying to understand how that works, and left her alone for 6 weeks without a task, and she, oops, just made a booklet out of it, because that was kind of necessary. Nathan, where's Nathan? Nathan, which you see in the Façade forward as a new speaker. We didn't find a chance to convince him to stay in Europe. He's going to go back to Australia in a month, no, in a half a month. Talia, where's Talia? Here. I come to this again. Alessandra and Talia got yesterday, midday, the notice that this is not going to happen in a different place, which we were supposed to, but has to happen here. You see all the video guys here. You saw the food which was already taken away. This room needs to be organized. Damn. Thanks for this. Thanks. Really, thanks for this. She's going to leave as well. She finishes on, as I said, Friday. Noor, where's Noor? There she is. Darmstadt student Efe, where is he? Efe is here. And Evgenia here. She's going to enter from the TU Delft side, and these two are from the Darmstadt side, which are ongoing for the program. I have to also say Hans de Junge, he's the video editor. Without him, these videos which Marcel and me started with a lot of crap, look at his face, how stressed he sometimes was with us. Oh my God. And then we lost audio. I learned in this video environment, video without audio doesn't work. Okay. Ludovica from Eurac. She's doing all the PR. Thanks to her. I'm not sure if she's online, but if you see her, say that she was announced. And then there comes a special thanks to Bea. There's one person who did participate in every single piece of this whole journey. True. There are about, say, 6 courses, of which 3 I really did not really, well, I did videotape most of the content, but I didn't take content in the whole, no, they come closer. And I have, again, I can add more to this. We had this very first meeting where you met Marcel and me. These guys are crazy. And actually, that's what already meeting some number 5 or something with any official of the university, which always feels like these guys are crazy. Then we had this other meeting after the first MOOC was finished, the coffee break with you and Tatjana. And you were at the coffee bar, and the two of us thought like, Naya, she was so pissed off of us in the beginning. She's going to pull our ears. And we were prepared to really get hit. And we were sitting in front of her, and she said, this is the new benchmark. Wow, this was really impressive. This was really cool. So thanks for that. Thanks for taking care, and also thanks for knowing how to handle characters like me or Alessandra or Marcel.
I need to say something myself, that it is true that you guys are totally bonkers. But I wouldn't have been able, it's all been teamwork. I would not have been able to handle you guys without having the help of Annabelle first, Nathan, and Talia to translate your madness into something that can be called education program, exactly.
Applause for this. So there's a 5th prize, which goes to you. You should have it in the office. Bunkers, madness. Okay. Social media. This is it. We're done. We're better in time than we expected. We are earlier finished. Sadly enough, catering already took it away. That's part of how we are handled in this system. I thank this gentleman who offered his place, which actually is having a nice tribune for this kind of audience. Next time we come to your place, and we get cold drinks as well. We close here. There's a barbecue, which is not supposed to be car barbecue, but it's on.
Number 4, yeah, at 5 o'clock. I would say it's a nice time to transfer over there. At our campus at the Faculty of Architecture, we are inviting you for a festive flamenco buffet, precisely. And that's the issue, because since years it's the EFN barbecue. I'm usually the guy who stands behind 2 meters of glowing fire and preparing various types of meat and whatsoever, which is, of course, another issue. But we are now a vegetarian faculty. In order to...
No, university.
No. Don't scare the others away. I think industrial design also shared our passion for the environment and try to reduce the meat. But we have from now on a flamenco buffet in a vegetarian style. So therefore, all invited over there with cold drinks at the Baupap. And in front we have a flamenco buffet. So that's it.
Bye-bye.